So this problem is about using the combined gas law, and we took this one, it's out of still chapter 5, number 48 in the back of the book. And it's like the modified version, but it's the same problem. So this one, we're going to analyze what happened in a balloon that was at a certain volume, the 28.5 liters, at a certain pressure at 28 degrees Celsius. And now the balloon, we release it into the atmosphere, it went up in the air, and the pressure drops to 385, and the temperature is negative 15 degrees Celsius. So we're solving for the new volume at the altitude that the balloon is at. Now, we have to remember that we have PV equals nRT, but in this situation, because the conditions are changing, we're going to use the combined gas law, which is PV over NT equals PV over NT. And now, if you remember, these are like the initials, the 1s and the 2s. So, in this situation, we have a certain first set and a certain second set. So the first set is going to be the 28.5, the 748, and the 20 degrees Celsius. In between these, the moles actually stayed the same because the balloon is going to have a certain amount of moles to start with and a certain amount of moles to finish. So we can actually cancel out moles. So now all we have to do is plug in the PV and T's for the first and the second and solve for the volume of the second, which is this guy. So that's the one we're solving for. So if we plug all this in, we're going to get 748 millimeters of mercury over this times the 28.5 liters, all over the temperature of 28 plus 273 to make it to Kelvin. And on the other side, we're going to get the pressure of 385 millimeters of mercury times this volume that we're solving for, all over the temperature, which is going to be 273 minus 15 Kelvin. So now all of our units cancel on both sides to get us our liters and liters. So it's going to be our final answer. So if you do all the math, multiply this out, add, do the subtraction, multiply it across, divide, your final V2 will be around 47.5 liters. So I know a few of you were asking last time if we had to change the pressure. We don't have to change the pressure to atmospheres in this situation because if we did divide by 760 on both sides, it was going to cancel anyways. So it's not wrong to change the pressure, but you don't have to in the situation because we're not using R directly and we're using millimeters of mercury on both sides. So as long as all of our units line up, we're good to go. And so that's why our final answer will be in liters.